Okay, in the previous video, we learned that when we are given a name, we can figure out what the formula is. And then in this video, I want to teach you how to do the reverse. What if you're given a formula and you have to figure out what the name is? What do? Well, if it's a fixed charge metal, it's really easy to do. You just name the metal, name the non-metal with the suffix "ide," and you're all done, okay? But if it's a variable charge metal, you have to figure out first what the charge of the variable charge metal is, and then you have to put it as a Roman numeral in the name. The Roman numeral is not going to be in the formula, it's going to be in the name. How do you know which ones are the variable charge metal? Remember what I told you guys. I said group 1A, group 2A, aluminum, gallium, zinc, cadmium, and silver are the fixed charge ones. Those are not going to change. So all the other metals are variable charge. Okay, so I put a few on the board here. This first one here, this is bismuth chloride. Now, can I just write bismuth chloride? Well, let me take a look at the periodic table. Is bismuth fixed charge? It's not group 1A, it's not group 2A, it's not aluminum, gallium, zinc, cadmium, silver, so it's variable charge. So I need to know what charge is bismuth. How do I do that? This is my little trick. Do a dotted line between the metal and the non-metal and figure out the charge of the non-metal. You already know that chlorides are halogens. They're in group 7A. They have a -1 charge. You know that. So you have 3 of them. -1 times 3 is 3 minus. So if this side is 3 minus, this side has to be 3 plus. Why? Because remember how we said they balance each other out. And since I only have one bismuth, that bismuth must be +3. So therefore, this is bismuth, Roman numeral 3. So we write the name of the compound, bismuth, Roman numeral 3, chloride. I just didn't have enough room on one line, but it's all one line. Okay? Let's do the next one. Here's an iron and here's an oxide. Is iron variable charge or fixed charge? It's variable charge. So that means we need to figure out what the charge is. Handy dandy dotted line. What's the charge on the oxide? We know it's a -2 because of what I just told you in the video before. It's group 6A, oxide, sulfide, selenide, they're all -2. So this is -2. So this side must be +2. Only have one iron, it's got to be +2. So now this is iron, Roman numeral 2, oxide. Okay? Let's go to this one over here. You recognize that this is a copper. Copper is a variable charge metal. Okay, what is its charge? Dotted line. We know that the sulfide is -2. So put a -2 here. So I have to put a +2 over here. But look at what happens here. You have 2 of them. So each one of them must be a +1. So this is copper, Roman numeral 1, sulfide. Total together is +2, but each copper is +1. So you write copper, Roman numeral 1, sulfide. The only way to get really, really, really good at this is to just practice. You got to practice and practice and practice, and you got practice on Canvas, you've got practice in the homework. Just keep on practicing. Write little, index cards of all the different ions, throw them in the air, pick up a metal and a non-metal, put them together and create some compounds, okay? All right, here's another one. Get this down a little bit. All right, you recognize that this is tin. Sn is tin. Again, that's why I told you in several videos ago that you got to know your elements. You can't just look at this and say, I have no idea what this is. So Sn, you know, is tin. You look at your periodic table. It is not in group 1A. It's not in group 2A. It's not in aluminum, gallium, zinc, cadmium, or silver. So it's a variable charge metal. And it's to the left of that zigzag line. So it's a metal. So dotted line. Oxygen, you know that the oxide is -2, but look, you have 2 of them. So -2 times 2, you have 2 of them. So that's a total of -4. And then this side has to be plus 4. I only have one tin, so this would be tin Roman numeral 4 oxide. So what you can see here is that anytime you have a subscript on the right side with a nonmetal, you multiply the charge by that subscript. Anytime you have a subscript on the metal, you divide the charge by that subscript so that you can figure out the charge on each thing. Okay, and then finally we have this one, sodium oxide. Do I need a Roman numeral with this one? Absolutely not. Why not? Because sodium is a group 1A metal. It's fixed charge, and just like I told you a little while ago, anytime you have a fixed charge metal, you don't need to worry about figuring out what the charge is. You already know what the charge is. You do not mention the charge in the name. You don't put a Roman numeral. In fact, it would be illegal to do that. You just write sodium oxide, and you're done. Okay? Good. All right, a couple of things before we move on to polyatomic ions. The old way of naming things, we used to use the Latin word for the element, and we'd put ic or us. What do I mean by that? Copper. Copper would be cupric or cuprous. Iron would be ferric or ferrous. Lead would be plumbic or plumbus. I'll explain this in a second here, guys. And then tin would be stannic or stannous. And N-O-U-S. All right, let me explain this. These two are copper. These two are iron, comes from the word ferrum. These two are lead, which is plumbum. And these two are tin. All right, the ic versus the us. The ic stands for the higher charge. The us is the lower charge. So if you know that copper exists as +1 and +2 and or +2, +1 is the us, +2 is the ic. So cuprous is copper +1, which would, in a modern terminology, would be copper Roman numeral 1. Cupric is copper +2, and in modern terminology it would be copper Roman numeral 2. So you need to know these terms, just especially these. I don't know if there are others that I need you guys to know, but you should know these ones. Always know that the ic is the higher number and the us is the lower number charge. Okay, ferric and ferrous. Iron exists as +2 and +3. So which one would be the ferrous? The +2, the lower number. So this is iron +2, and this is iron +3. So when I write the modern way of doing it, this would be iron Roman numeral 2, and this would be iron Roman numeral 3. So if I had that thing that I had earlier, FeO, instead of writing iron Roman numeral 2 oxide, you could write ferrous oxide, okay? And if you use the term ferrous or cupric or stannous or stannic or plumbic or plumbus, you don't put the Roman numeral. That us-ic tells you it's instead of the Roman numeral, okay? Plumbic, plumbus. Well, we know that lead exists as +2 and +4. So this one is the +4. This is the +2. So Pb +4, Pb 2+. This would be lead, Roman numeral 4. And this is lead, Roman numeral 2. And then finally, stannic and stannous. This is your tin. So this is Sn4+, and this is Sn2+. This is tin, Roman numeral 4, and this is tin, Roman numeral 2. Okay, so when we're doing the nomenclature quiz, you need to know this terminology, the ik, us terminology. If I tell you to write the formula of plumbic sulfide, what is plumbic sulfide? That would be lead Roman numeral 4 sulfide. Okay, good. Now we're ready to move on to polyatomic ions. What are polyatomic ions? These are a group of elements bonded together. So atoms of elements bonded together. And they're usually bonded together by covalent bonds, but they have an overall charge. So that's why it's called polyatomic. It's many atoms. So before we were dealing with monoatomic ions. A lead plus 2 ion is one atom, one type of atom. But polyatomic means several different types of atoms. You've heard of nitrites and nitrates in your cured meats. Those are polyatomic ions. It has several different atoms in them. And a lot of these polyatomic ions are called oxoanions. Why are they oxoanions? Oxo because they have oxygen in them, and anions because they're negatively charged. So your book has a table with a whole bunch of polyatomic ions in it. And on Canvas, I've given you quite a few. Let me try to find the table if I can find it easily here. I have the book. Okay, it's on page 61. Oh no, that one is oxoanions for acids. We'll get into acids in a little bit. Here it is. It's on page 55, some common polyatomic ions. Here we go. This formula here, this table here. It's table 2.6, some common polyatomic ions. Let me just mention a few of them, and then you just need to know, you definitely need to know the table. And I'm going to give you a few more than just the table. So starting off with nitrate. Nitrite. Okay, one way to remember this is to create index cards for each polyatomic ion. Write it on one side and write the name on the other side. So you need to know the formula and the charge. This is nitrate, and this is nitrite. What will help you is that the ite always has one less oxygen than the ate. So nitrate here has, so if you've memorized nitrate, then nitrite is easy to memorize because it just has one less oxygen. They both have the exact same charge, but this has one less oxygen than this. Okay, so in the next video, I'm going to talk about all the other polyatomic ions that you need to know and give you some tips on how to memorize them, and then we'll create some compounds that contain polyatomic ions. Okay, good.